The equidistant concept in coordinate geometry is pretty simple when you just have numbers, but I know that some of you might be panicking when you look at a lot of variables in them. Hello everyone, welcome to Leap, where you learn once and remember forever. In this video, we are going to see one such problem where you have to prove an equation that involves a lot of variables. Let's try to make this solution as easy as possible. Let's read this question together. If the point P is equidistant from the points Q and R, then prove that bx is equal to ay. Now we know all the coordinates of P, Q and R. So when they say equidistant, what does that mean? Equidistant means equal distance. So this particular point P, is equidistant from Q and R. So let's try to draw it to understand it better. So I can say that there are 2 points. There is point Q, point R, and point P. So the question says point P is equidistant. That means it is at equal distance from point Q and point R. So these two lengths are equal. And we know the coordinates. Point P has coordinates x, y, and point Q has coordinates a plus b, b minus a, and point R has a minus b, a plus b. That's it. So we know that they are equidistant. So our first thing given, which is PQ equals PR. They have already given it. We are supposed to prove that BX equals AY, right? Okay, now let's start proving. Proof. So as we begin with the given statement, which is PQ equals PR. Okay. Now just for easy understanding, I'll just write the distance formula here. We know that it is x1 minus x2 the whole squared plus y1 minus y2 the whole squared. This is the distance formula. When you have 2 points, the distance between the 2 points is calculated using distance formula. Now applying it back here. So PQ and PR, when you directly substitute the formula here, what happens is you will end up getting a square root on the left hand side and the right hand side. In order to avoid that, it is always good to remove the square roots. Now, how do you remove a square root? You have to square the square roots, right? So when you square it, you will square both the left hand side and the right hand side. So squaring on both sides, we get PQ squared equals PR squared. Now when you write, you don't have to write the square root. You just have to substitute inside the formula and just write it without the square root. So PQ means you will choose this point and this point. So X becomes your X1, A plus B becomes your X2. All right. So X minus, and since A plus B is a binomial, use a bracket. So A plus B the whole squared. So we are done with the first part. Plus. Now do y1 minus y2 the whole square. So y is your y1 minus, again a binomial, and then whole square. So left hand side is done. Now let's do the right hand side. Again, P with R. This is your value. So x minus a minus b the whole square plus y minus a plus b the whole square. Now we have to simplify this. It looks complicated, but trust me, it is not as complicated as you think. All right, so this looks like again an identity. So A minus B the whole squared. So your A is X, your A plus B will be your B. Okay. So what is A squared? That is X squared plus B squared. B squared is A plus B whole squared, because this whole term is B. So the entire thing raised to 2. Next is minus 2AB. So minus 2 times A is X and B is A plus B. It can be quite lengthy, but still doable. Now the next term is, we are going to apply identity here. Again, a minus b whole squared is the identity. So what happens? You get y squared, which is a squared, plus b squared is b minus a the whole squared, and then negative 2 times a times b. Your a is y and your b is b minus a. Similarly, we have to open up the right hand side. So what happens? A squared is x squared plus a minus b the whole squared minus 2 times a times b. Same way, plus, do it for the second part, which is y squared plus a plus b whole squared minus 2 times a times b. Right. So before you begin to simplify this further, you have to check if you have any similar terms on the left hand side and right hand side so that you can cancel them out. So you can see here, you have x squared, positive x squared, positive x squared. So when they transpose, they become the opposite signs and they get cancelled out. So you can do it right here. Same way, positive y squared, positive y squared. Again, I have a plus b whole squared and a plus b whole squared. Now let's simplify the remaining terms. So minus 2x, you can times it with a, you get minus 2xa, and minus 2x times it by b, you get minus 2xb. Again, this can be opened with the identity. So what do you get? You get a squared plus b squared minus 2ab. And again, when you simplify using distributive property here, minus 2y times b gives minus 2yb, and then minus 2y times minus a gives positive 2ya. Now when I do the right hand side, a minus b the whole squared, I get a squared plus b squared minus 2ab. And then when I simplify this using distributive property, I get negative 2xa. Negative times negative is positive 2xb. And then I have again distributive property. I get negative 2ya. Negative times positive is negative 2yb. Again, before proceeding, just check if there is anything that can be cancelled. So I have a negative 2xa, negative 2xa. And then we have negative 2yb and a negative 2yb. We have a negative 2ab, negative 2ab, positive b squared, positive b squared, positive a squared, positive a squared. Now we are left with hardly 4 terms. Let's try to rewrite them. So we are left with negative 2xb plus 2ya equals positive 2xb, negative 2ya. The entire equation is divisible by 2, so we can divide it by 2 and we get negative xb, positive ya, positive xb and negative ya. So what I'm going to do is I'm going to rearrange the like terms together. So while trying to rearrange, what I'm trying to do is I'm going to keep the positive terms on the left. So ya, I'll transpose this to the other side and this over here. So I get ya plus ya equals this xb is already here, and then negative xb becomes positive xb. When you add, you get 2ya. This is 2xb. Now simplifying further, ya equals xb. And you can see that you need bx equals ay, which is the same. So therefore, bx equals ay, hence proved. So that's it, we are done. I hope you were able to understand, and I know that there were so many variables involved and it is quite taxing. But if you write legibly and solve it patiently, you should be able to reach the answer. Thank you so much for watching.